Unix is a family of multitasking, multi-user computer operating systems that derive from the original AT&T Unix, developed in the 1970s at the Bell Labs Research Center by Ken Thompson, Dennis Ritchie, and others. Initially intended for use inside the Bell system, AT&T licensed Unix to outside parties from the late 1970s. Leading to a variety of both academic and commercial variants of Unix from vendors such as the University of California, Berkeley, Microsoft, IBM and Sun Microsystems. AT&T finally sold its rights in Unix to Novell in the early 1990s, which then sold its Unix business to the Santa Cruz operation in 1995. But the Unix trademark passed to the Industry Standards Consortium, the Open Group, which allows the use of the mark for certified operating systems compliant with the single Unix specification. Among these is Apple's OS X, which is the Unix version with the largest installed base as of 2014. From the power users or programmers' perspective, Unix systems are characterized by a modular design that is sometimes called the Unix philosophy, meaning that the operating system provides a set of simple tools that each perform a limited, well-defined function, with a unified file system as the main means of communication and a shell scripting and command language to combine the tools to perform complex workflows. Aside from the modular design, Unix also distinguishes itself from its predecessors as the first portable operating system. Almost the entire operating system is written in the C programming language that allowed Unix to reach numerous platforms. Many clones of Unix have arisen over the years, of which Linux is the most popular, having displaced certified Unix on many server platforms since its inception in the early 1990s. Overview. Originally, Unix was meant to be a programmer's workbench to be used for developing software to be run on multiple platforms, more than to be used to run application software. The system grew larger as the operating system started spreading in the academic circle, as users added their own tools to the system and shared them with colleagues. Unix was designed to be portable, multitasking and multi-user in a time-sharing configuration. Unix systems are characterized by various concepts. The use of plain text for storing data, a hierarchical file system, treating devices and certain types of inter-process communication as files, and the use of a large number of software tools, small programs that can be strung together through a command line interpreter using pipes, as opposed to using a single monolithic program that includes all of the same functionality. These concepts are collectively known as the Unix philosophy. Brian Kernel and Rob Pike summarize this in the Unix programming environment as the idea that the power of a system comes more from the relationships among programs than from the programs themselves. By the early 1980s, users began seeing Unix as a potential universal operating system, suitable for computers of all sizes. Unix operating systems are widely used in servers, workstations, and mobile devices. The Unix environment and the client-server program model were essential elements in the development of the Internet and the reshaping of computing as centered in networks rather than in individual computers. Both Unix and the C programming language were developed by AT&T and distributed to government and academic institutions, which led to both being ported to a wider variety of machine families than any other operating system. Under Unix, the operating system consists of many utilities along with the master control program, the kernel. The kernel provides services to start and stop programs, handles the file system and other common, low-level tasks that most programs share, and schedules access to avoid conflicts when programs try to access the same resource or device simultaneously. To mediate such access, the kernel has special rights, reflected in the division between user space and kernel space. The microkernel concept was introduced in an effort to reverse the trend towards larger kernels and return to a system in which most tasks were completed by smaller utilities. In an era when a standard computer consisted of the hard disk for storage and a data terminal for input and output, the Unix file model worked quite well, as most I/O was linear. However, modern systems include networking and other new devices. As graphical user interfaces developed, the file model proved inadequate to the task of handling asynchronous events such as those generated by a mouse. In the 1980s, non-blocking I/O and the set of inter-process communication mechanisms were augmented with Unix-style main sockets, shared memory, message queues, and semaphores. In microkernel implementations, functions such as network protocols could be moved out of the kernel, while conventional Unix implementations have network protocol stacks as part of the kernel. History. The prehistory of Unix dates back to the mid-1960s when the Massachusetts Institute of Technology, AT&T, Bell Labs, and General Electric were developing an innovative time-sharing operating system called Multics for the GE 645 mainframe. Multics introduced many innovations, but had many problems. Frustrated by the size and complexity of Multics but not by the aims, Bell Labs slowly pulled out of the project. Their last researchers to leave Multics, Ken Thompson, Dennis Ritchie, D. McIlroy, and J. F. Ossanna, decided to redo the work on a much smaller scale. The name UNICS, a pun on Multics, was initially suggested for the project in 1970. The new operating system was an emasculated Multics. Peter H. Salis credits Peter Newman with the pun, while Brian Kernighan claims the coining for himself, and adds that, "No one can remember who came up with the final spelling Unix." Dennis Ritchie also credits Kernighan. In 1972, Unix was rewritten in the C programming language. The migration from assembly to the higher-level language C resulted in much more portable software, requiring only a relatively small amount of machine-dependent code to be replaced when porting Unix to other computing platforms. Bell Labs produced several versions of Unix that are collectively referred to as Research Unix. In 1975, the first source license for Unix was sold to faculty at the University of Illinois Department of Computer Science. UIUCE graduate student Greg Chesson was instrumental in negotiating the terms of this license. During the late 1970s and early 1980s, the influence of Unix in academic circles led to large-scale adoption of Unix by commercial startups, including Sequent, HPUX, Solaris, X, and Xenix. In the late 1980s, AT&T Unix System Laboratories and Sun Microsystems developed System V Release 4, which was subsequently adopted by many commercial Unix vendors. In the 1990s, Unix-like systems grew in popularity as Linux and BSD distributions were developed through collaboration by a worldwide network of programmers. In 2000, Apple released Darwin that became the core of the OS X operating system standards. Beginning in the late 1980s, an open operating system standardization effort now known as POSIX provided a common baseline for all operating systems, IEEE-based POSIX around the common structure of the major competing variants of the Unix system, publishing the first POSIX standard in 1988. In the early 1990s, a separate but very similar effort was started by an industry consortium, the Common Open Software Environment Initiative, which eventually became the single Unix specification administered by the Open Group. Starting in 1998, the Open Group and IEEE started the Austin Group to provide a common definition of POSIX and the single Unix specification, which, by 2008, had become the Open Group-based specification. In 1999, in an effort towards compatibility, several Unix system vendors agreed on SVR4's executable and linkable format as the standard for binary and object code files. The common format allows substantial binary compatibility among Unix systems operating on the same CPU architecture. The file system hierarchy standard was created to provide a reference directory layout for Unix-like operating systems, and has mainly been used in Linux. Components. The Unix system is composed of several components that were originally packaged together, by including the development environment, libraries, documents and the portable, modifiable source code for all of these components. In addition to the kernel of an operating system, Unix was a self-contained software system. This was one of the key reasons it emerged as an important teaching and learning tool and has had such a broad influence. The inclusion of these components did not make the system large. The original V7 Unix distribution, consisting of copies of all of the compiled binaries plus all of the source code and documentation, occupied less than 10 megabytes and arrived on a single 9-track magnetic tape. The printed documentation, typeset from the online sources, was contained in 2 volumes. The names and file system locations of the Unix components have changed substantially across the history of the system. Nonetheless, the V7 implementation is considered by many to have the canonical early structure. Kernel, source code in USR, sys, composed of several subcomponents. CONF, configuration and machine-dependent parts, including boot code, dev, device drivers for control of hardware, sys, operating system, kernel, handling memory management, process scheduling, system calls, etc. H. Header files, defining key structures within the system and important system-specific and variables. Development environment. Early versions of Unix contained a development environment sufficient to recreate the entire system from source code. C language compiler as machine language assembler for the machine, LD linker for combining object files, lib object code libraries. libc, the system library with C runtime support, was the primary library. But there have always been additional libraries for such things as mathematical functions or database access. V7 Unix introduced the first version of the modern, standard I/O library Studio as part of the system library. Later implementations increased the number of libraries significantly. Make Build Manager, for effectively automating the build process, include header files for software development, defining standard interfaces and system invariants. Other languages. V7 Unix contained a Fortran 77 compiler, a programmable arbitrary precision calculator, and the awk scripting language. Later versions and implementations contain many other language compilers and toolsets. Early BSD releases included Pascal tools, and many modern Unix systems also include the GNU compiler collection as well as or instead of a proprietary compiler system. Other tools, including an object code archive manager, symbol table lister, compiler development tools, and debugging tools. Commands. Unix makes little distinction between commands for system operation and maintenance. Commands have general utility, and more general-purpose applications such as the text formatting and typesetting package. Nonetheless, some major categories are SH, the shell, programmable command line interpreter, the primary user interface on Unix before Windows systems appeared, and even afterward. Utilities, the core toolkit of the Unix command set, including cp, ls, grep, find and many others. Subcategories include system utilities, administrative tools such as mkfs, fsck, and many others. User utilities, environment management tools such as parse, wd, kill, and others. Document formatting. Unix systems were used from the outset for document preparation and typesetting systems, and included many related programs such as nroff, troff, tbl, eqn, refer, and pick. Some modern Unix systems also include packages such as tex and ghostscript. Graphics. The plot subsystem provided facilities for producing simple vector plots in a device-independent format, with device-specific interpreters to display such files. Modern Unix systems also generally include X11 as a standard windowing system and GUI, and many support OpenGL communications. Early Unix systems contained no inter-system communication, but did include the inter-user communication programs mail and write. V7 introduced the early inter-system communication system UUCP, and systems beginning with BSD release 4.1c included TCP/IP utilities. Documentation. Unix was the first operating system to include all of its documentation online in machine-readable form. The documentation included manual pages for each command, library component, system call, header file, etc. Longer documents detailing major subsystems, such as the C language and TROF.